Hello friends. Welcome to T Academy. Now, I would like to discuss Tamil Nadu Electricity Board 2018 AW Assistant Executive Engineer and electrical paper I am going to discuss now. So, I am going to discuss directly the part 3 of this paper. Okay. So, let's start the first question here of this series. Okay. So, let me adjust the screen here. Now, the first question here it is, the magnetic flux has the unit of. So here it's a basic question. This question will be useful for all the competitive exams which belongs to electrical examinations. Okay. The magnetic flux has a unit of. What is the magnetic flux? Flux has a unit of Webers. Suppose if they ask magnetic flux density, so don't confuse with this flux and flux density. If they ask what is a magnetic flux density units, so magnetic flux density is denoted by letter B, which is nothing but flux per unit area. So it is nothing but Webers per meter square. So this is for magnetic flux density, and the magnetic flux has the units of Weber. Okay. Or it has another meaning. It is the 10 power 8 lines of force. So a magnetic flux means it is a 10 power 8 lines of force, or it is having units of Webers. Okay. Next question, we will move here. It is a 57th question here in this part 3. If a current of 10 amperes flow for 4 minutes, find the quantity of electricity transferred. Okay. So actually here, as you see the options here, it is all are in coulombs. C for not current, it is in coulombs, remember here. But the question is asked is the quantity of electricity transferred. Actually here the question itself, it's a little bit tricky, but you have to see the options here. All the options are in coulombs, not C for current, as you know. Okay. Now here the current is given. So current I is given how much? 10 amperes they given, and the time given is T is how much? 4 minutes. It can also be written as we know, 1 minute is equal to 60 seconds. So I can write as a 4 into 60 seconds. As you know, 4 into 60 means 240 seconds. Now we need to find the charge. So the basic formula is I is equal to current is equal to Q by T. So this is the formula you need to remember. Okay. Now from this they asked Q value. So Q is nothing but I into T. Now what is the I? I is nothing but the current. How much current they given? It is given 10 amperes. Okay, 10 amperes into time. Here the options are 40Z, 240Z. If you take the time 4 minutes means you will get answer 40. That's a wrong. Why? Because it has to be represented in seconds. So 10 into, we will convert this 4 minutes into seconds. So that we will get 4 into 240. Okay, it is in how much? 4 into 10 in seconds. Okay, now it is 240 into 10 means 00 ampere seconds. So ampere seconds is a unit of charge. We can also represent it as 2400 as coulombs. Okay. So among the options, I think C is the 4 is the right answer for this question. Okay. I will move to the next question here. Okay. So these are the simple questions which you can find in almost all the competitive exams, basic questions. The voltage across a 1 microfarad capacitor is 10 volts. For t less than 0, at t is equal to 0, 1 mega ohm resistor is connected across the capacitor terminals. Find the time constant. The voltage at V of t is equal to, actually here spelling mistake is it, so it should be T. So T is equal to 1 second is. So first what here it is, the voltage across 1 microfarad capacitor is given. Okay, if we take 1 microfarad capacitor here, so let me draw a capacitor. The voltage across it is how much? 10 volts, and the capacity is 1 microfarad at t is equal to 0. So when the switch is in open condition. Okay, now a 1 mega ohm resistor, a 1 mega ohm resistor is connected across the capacitor terminals. So capacitor terminals connected. Okay. Find the time constant for the voltage at t is equal to 1 second. So we need to find first a time constant. After that, voltage across the t, V of t, after switching is closed. So at t is equal to 0, it is in open state. Okay. So at t is equal to t equal to 0 minus, t equal to 0 minus, it is in open state. At t is equal to just 0 plus, it is in closed state. Now first we will find the time constant. So time constant tau for a RC network is, it is R into C. Now R value is 1 into 10 power 6 mega ohms now, into capacitance value is 1 microfarad, means 10 power minus 6. So finally you will get 1 second. So time constant means it has no units, t is equal to 1. Okay. So t is equal to 1. Now next one, time constant is 1 second. Next one, what we need to find? Voltage across the resistor here, both are in parallel. So voltage across the resistor we need to find. Okay, after t is equal to 1 second here. Now this formula is applicable when there is no source here. Why? Because capacitor itself acts as a source. Okay, V of t is equal to, so Vs into e power minus t by tau. Now Vs is what? It is supply voltage. How much it is? It is already 10. Now e power minus, so small t, it is 1 divided by t we need to find. So tau value we found, it is a 1. Okay, so from this case we all found. Now it is 10 into e power minus 1 by 1 is e power minus 1. As we know, e power minus 1 means 0.367 into 10. Now by solving this we will get as 3.67 units or volts. Now the answer is, as you know, it is t is equal to 1 second and 3.67 volts is the right answer for this question. Okay, we will move to the next question. It's a very simple question here again. Okay, this type of question is useful for competitive exams, especially like AE exams. Okay, a network has 12 branches. So B, how much given? Branches are 12 and 8 independent loops. So loops how many given? 8. And how many nodes are there in the network? How many nodes are there in the network? We need to find the n, is a question mark. Now you remember this formula, number of independent loops is equal to total number of branches minus number of nodes plus 1. Substitute these values in this formula, you will get the answer as usually. So 8 is equal to, B is nothing but 12 minus n plus 1. If you send this 1 to the left side, it becomes 7 is equal to 12 minus n, and from this n is equal to 12 minus 7. It is how many? Number of nodes are 5 nodes. So answer is 3 is the right answer for the question. We'll move to the next question here. Sorry. Now next question. When a uniform line charge of minus 6 microcoulomb per meter lies along the y-axis, what is the net electrical flux crossing the surface of the cube side 2 meters centered at the origin? Now there is a charge. How much it is? Charge per meter is minus 6 microcoulomb per meter. It's a line charge. Okay, line charge. Now it is a crossing a cube. Okay, it's a crossing a cube of how much length? How much length is it? It is 2 meters. Now we need to calculate the charge, total charge. So qt is equal to, so minus 6 microcoulomb per meter into, it is, the length is 2 meters. So how much finally it is? It is minus 12 microcoulomb. So answer is 3. So similar kind of problem which we solved in the UPPCL AE paper. So if you want, you can review that video from my channel. Similar kind of problems we solved in that exam also. Okay, so AE exams following certain standard questions. Okay, so if you want to crack your AE exam, so please solve all the AE exams of the other states and prepare well. Okay, so why? Because the same questions may be repeated in your exam also. The exam is going to set the questions from the other competitive exams and they will choose a question and they will ask the question. Okay, so if you are preparing, prepare for other exams also. Okay, we'll move to the next question here. Now, two identical coaxial circular coils carry the same current I but in opposite directions. So both are carrying current in opposite directions. The magnitude of the magnetic field B at the point on the axis midway between the two coils is. Now, for example, let me draw a line, straight line here like this. Now there is a one coil, coaxial coil like this. Okay, and there is another coil here. Now these two coils carrying currents in opposite directions. So let me take plus minus here, and opposite direction means if the current is flowing in this direction, so it is also flowing in opposite direction. So plus here, minus here. Now when these two coils are carrying currents in opposite directions, the magnetic flux at the midpoint between these axis is 0. Okay, next question. Next question. When port 1 of 2-port circuit is short circuited, I1 is equal to 4 into I2 and V2 is 0.25 times that of I2. Which of the following is true? In among all the given 4 options, it is common point you can observe here, it is all are admittance parameters. Okay, so for that we'll take the admittance parameters equation. So I1 is equal to V1 Y11 plus V2 Y12 and I2 is equal to, as you know, yes, it is V1 into Y21 plus V2 into Y22. Okay, now among these 4 variables of Y11, Y12, Y21 and Y22, which you can find here, observe. For example, if you want to find Y11, so Y11 if you want means I want to know the value of I1, okay, divided by V1 at V2 is made 0, but you know the value of Y11. Okay, so what is the I1? 4 into I2. V1 value is, no, you don't have any V1 value here. Okay, so that's why it's not possible. Similarly, if you check all the options, I may choose an option Y12. So Y12 is nothing but I1 divided by V2. So I1 divided by V2. So I1 value at V1 equals 0. I1 value, you know how much it is? 4 into I2 divided by V2 value is no 0.25 into I2. I2 gets cancelled. 4 divided by 0.25 means you can also written as 1 by 4. So finally it can be written as 4 into 4 means 16 and the units are Siemens. So Y12. So remaining options also you can check and this will be the correct answer. Okay, so Y12 is 16. Okay, we'll move to the next question here. The hysteresis losses is computed using the equation. So hysteresis losses can be computed by using this equation, Siemens equation. It is PH is equal to KH into B max. So here B is nothing but it is maximum flux density, and F is nothing but here it is frequency. And remember that the hysteresis losses is always proportional to frequency. Eddy current loss is proportional to F square. Remember, this is a very important question, basic question in transformers. Now what is this 1.6 resembles here? So 1.6, what is it is? So 1.6, it's a constant for silicon steel. Okay, silicon steel. Okay, now we'll move to the next question here. A star winding supplied from a 3-phase 60 Hz system, okay, is required to produce a magnetic flux rotating at 900 revolutions per minute determine the number of poles. Now general formula here it is Ns is equal to 120 F by P, as you know basically. Now but the magnetic flux rotating at the specified rate as 900 revolutions per minute. Okay, the speed is given in RPM. Now we will take it as 900 is equal to, so 120, frequency is how much, 60 hertz divided by number of poles P. Okay, so from this we need to find the poles. So poles is equal to 900 divided by 120 into 60. Okay, now if you calculate this simply, sorry, I made a mistake here, it is reverse, 1 by P you can take. Okay, so P is equal to 120 into 60 divided by 900, please make it correct, and this will be equal to 8. So among the options, 1 is a right option for this question. So thank you friends, thanks for watching my video. If you like this video, please subscribe, share and comment here. So your comments, based on your comments, I will make the next video. Okay, thank you, have a nice day. Hi, hello friends, welcome back to my YouTube channel T Academy. Now let's continue the TNEB electrical paper solutions. So let's continue the solutions here, and we have the question 65 here. The speed of the rotor field flux with respect to the stator in a 50 Hz supply, 4-pole induction machine running at 1% slip. So friends, remember here, read the question carefully. Here they are asked to find the speed of the rotor field flux, not the rotor speed. Okay, so actual physical rotation of the rotor is different, rotor field flux is different. Generally this rotor field flux rotate at synchronous speed. Remember here, both the stator field as well as rotor field flux, I am writing the point here, both fields. So field flux of stator and rotor are rotate at synchronous speed. Okay, the rotor physically rotate at a rotor speed which is phi r. Okay, I will write the formula here. So first, the stator and the rotor field flux rotate at a speed of Ns is equal to 120 F by P. I will write the formula of rotor. Nr is equal to Ns into 1 minus S. Here the asked the question is rotor field flux. Suppose if they ask rotor speed means use this formula. If you are using this formula and substitute the values, so for example Ns, first you will find Ns value. Ns is how much, 120 into F is how much, 50 Hertz divided by how many poles, 4. So as you can get, it is a 1500 RPM is our answer. So answer is 1500 RPM for this question. Suppose if they ask, instead of asking this flux, they will ask only what is the speed of the rotor, then take this formula. Ns is how much, it is already we found 1500 into, so 1 minus slip is how much, 1%. 1% means 1 part of 100. If you solve this, we will get 1500 into, so 100 minus 1 means 99 divided by 100. You will get approximately it as 1485 and the speed is in RPM. So see here in the given options, you may face this option 1485 also there, and difference between the 1500 and 1485 also there. So in this manner the examiner is trying to confuse you if you lack of concept. Okay, now suppose somebody think that rotor speed is maybe 1500 into 2 times, so you'll get a 3000. So all the options are there in the examination, you have to choose an option correctly, right? So for this question exact answer will be 1500. If they ask what is the speed of the rotor means, it is 1485. Difference between the actual speed and the rotor speed is 1500 RPM. Okay, now you hope you get the answer. We will go to the next question in the machines, right? Next question friends, see here. A synchronous machine is connected to an infinite bus. First identify what is the infinite bus. Infinite bus will have a bus which will have a constant voltage and constant frequency. Okay, remember the armature current change with field current. So armature current changing with the field current for a constant real power is. So power is maintained constant here. Power is maintained here constant. So P is equal to VI into cos phi. Now we need to draw the curve here. So we need to draw the curve. Already we know this concept here. In the previous exams questions I discussed all these points. Okay. So standard question, friends. Now we need to draw the armature current and field current. So if you draw this relationship between armature current and field current for different excitations. Okay, so for excitations, so here we have normal excitation, and here we have under excitation, and here we can call as a over excitation. Now if you see here, the shape will be just like this. Okay, it's like a V curve. It's not a inverted V curve. Suppose if they ask question that what is the curve between the field current and the power factor. So if they ask the power factor, means you can say the answer it has a inverted V curve. But the question is they asked is the armature current with field current. Armature current with respect to field current only. If they ask, for example, I will strike out this. I will ask it as a power factor. So power factor means it is a inverted V curve. So understand this question. The correct answer for this question one is A. And the next question will be inverted V curve means it is a power factor and the field current. Okay, so next we'll move to the next question here. Hope you are understanding. Okay, now third question. So it is from induction machines. An induction machine is operated with two values of frequencies with the ratio of 1:2. So for example, first one is F1, second one will be 2 times that of first one. So without changing voltage. So here no change in voltage. Then the starting torque of the machine for the two cases will be in the ratio of, remember here, starting torque is inversely proportional to speed. Okay, remember. So TST is inversely proportional to NS, means we can write it as a synchronous speed, as you have seen in the previous case formula, right? NS is equal to 120 F by P. I can say that starting torque is inversely proportional to frequency here. Okay, now as they are changing the frequency, let me take here formula here. So first time frequency is, let me say F1, F2 will be how much? 2 times that of F1. So this statement is given in the question itself. Now second case, when you operate the higher frequency, what will be the starting torque? Now I will take the formula here. Starting torque TST1 divided by TST2. If I remove proportionality and made it equal, I can say F2 by F1. Now the question is, then the starting torque of the machine for the two cases will be, let me take T1 and T2 ratios. Okay, F2 is how much? 2 into F1. Already we know here it is F1. It is nothing but 2:1 ratio. So the answer here it is, as you can see, it is 3 is the right option for this question, right? Now we'll move to the next question here. In a stand-alone synchronous generator, so only one alternator is there, it is working. Okay, one alternator is there. Impact of increase in real power. So if you are increasing real power, means you need to increase the mechanical power, right? Not excitation. Excitation will be kept constant. Now if you increase the real power, okay, load with governor valve control. So we here we have, so governor valve control is there. So if governor is just like to control the speed, so NS you need to control the speed. NS is proportional to 120 F by P. So if you are controlling the speed here, automatically frequency will be controlled. So frequency control means, as we know that we will not allow the frequency variations much. So it is to maintain the frequency. So answer is 68 is to maintain a constant frequency, we are going to use the speed governors or governor valve control we are going to use here. Next one. Next, it is a little bit interesting question here. It is from DC machines. So friends, observe here. A differentially compound DC generator. So differentially compound generator in which we have two windings, right? Series winding and shunt winding, as you studied, has its series and shunt field providing 20% and 80% of the flux respectively. Okay, so series field winding is providing 20% and shunt field is providing 80%. the series field is suddenly short circuited, that means you remove this 20%, okay, then so the series field winding suddenly short circuited without changing the load, so load is remain as it is, then the terminal voltage ignoring all the resistances, so terminal voltage you should calculate here. Now first of all, see here, generally in a differential compound machine the EMF is proportional to, it's a difference between two fluxes, right? So I will say shunt minus series. I will say first case when the both are working, let me take here, when the both are working, difference between 2 means 80 minus 20, it will be around 60%, right sir? No. Now second case, when you made a short circuit here, short circuit means it's a straight short circuiting. Short circuiting means as MMF is equal to N into number of turns into current. So as a number of turns are only 1, okay, so MMF will be reduces. I will say the series flux when you short circuit, the series flux will be 0, I am assuming, okay, it will be very small, it will be negligible. Now phi s is 0. Now E is proportional to phi sh minus 0, that means how much it is? It is already 80%, it is remain same. So difference between these two, difference between 60% and 80% is how much? 20%, either increasing or decreasing. First case 60%, second case is 80%, so increase, yes, so it is increases by 20%, okay. Understand this question? Okay, next we will move to the next question here. Okay, right, this one. Now 70 question. A 200 bar 100 volts 50 hertz transformer is to be excited at 60 hertz from the primary side without increasing the excitation current. So here the keyword is excitation current. So excitation current is not going to change, it is remain same. Then the voltage to be applied at primary. The basic formula we are going to take here. Generally we will take a transformer here to understand the concept what they are asking. Okay, transformer is there. Primary is how much? 200 volts. Secondary is 100 volts. Generally its rating is given how much? Primary is 50 hertz. Now what the question is made is, it is given excitation at 60 hertz. Normally it has to work at 50 hertz, but they given 60 hertz from the primary side without increasing excitation current. Excitation current means excitation flux, or I can say excitation, okay. Now we will take the formula. E is equal to 4.44 FAN into B. Now excitation is constant means B is proportional to phi, it is constant. So B is constant, number of turns is also constant, area is constant. So simply E is proportional to F, I can say. E is proportional to frequency. Now same relationship as we discussed earlier. E2 by E1 is equal to F2 by F1, okay. Now as E2 is equal to E1 into F2 divided by F1, E1 is say how much you are going, so you are giving the voltage at 200 volts, right, 200. Now I will take 200, frequency increased is how much? 60, 10 hertz increased here divided by 50. Now if you solve this, you will get a 240 volts. So 240 volts is a right answer for this question. Among the options you can choose here, okay. Next question. This question is from the power systems. Observe, in which type of fault the negative and zero sequence currents are equal to 0. Remember here the examiner asked a question which may confuse you. Why? Because in LL fault both negative currents, in a LG fault, negative currents zero sequence are equal, but they are not to 0. Understand why? Because if you study LG fault, you can say IA1 is equal to IA2 is equal to IA0, yes or no, right? But here they are made to equal to 0 here. So option is 3-phase symmetrical fault, okay. And LL fault zero sequence currents will be, so IA0 will be 0, zero sequence current will be 0 because there is no ground involved here. Understand? So the answer here is 3-phase symmetrical fault. While reading the question, be careful here, it is made equal to 0. If not equal to 0 means you can say it is a LG fault, obviously. Okay, next question. It is the 72 question here. Okay, I hope you are learning something from these lessons, okay, classes. Now next question here, right? An 800 kV transmission line has a maximum power transfer capability of P. So maximum power transfer capability is how much? So let's say P max is equal to P the given. Okay, when operated at 400 kV with the series reactance unchanged, so XS is not changed, it's a simply I can say constant. The new maximum power transfer capability is approximately, the basic formula here it is, as you know, P is equal to EV by X into sin delta. If we neglect the delta angle, okay, if you assume the delta equal to 90, then you can remove this and you can write as a P is equal to EV by X. But again you are making assumption that E is equal to V, then P is equal to I can say V square by X, but in this case X is constant. So simply I can say P is proportional to V square, understand? Now P2 by P1 is equal to V2 square by V1 square. Now here take this value. So P2 by P1 is equal to V2 is decreased. How much? 400. Earlier it was acting, earlier we are using the transmission line to transmit the power at 800 kV. Now we operate at 400 kV. So P2 V2 square means how much? 400 into 400 divided by 800 into 800. I am cancelling kV square here and kV square here. So both get cancelled. Now see here 0 0 0 0 0 0 0 0 here. Okay. Now 16 by 64. So 1 ja 4 ja here. So P2 is equal to P1 by 4. Okay. So the final answer here it is fourth one is a right option for this question. Okay. And the next very important question, okay, common question which may be asked in any examinations. Okay. Now the reactance relay is it's a standard question. If you see the CL Wada textbook, you will see this first page questions. All these are first page questions, and these are important for any competitive exams, especially AE exams. Now I will give a hint to remember this question how it is. Now first of all, not a hint, actual concept here it is. We will take the torque equation, universal torque equation. So it is T is equal to, so K1 into I square plus K2 into V square plus K3 Vi cos phi plus K4 here. Remember here for reactance relay, the constant K2 will be made equal to 0. So when the constant K2 equal to K2 means voltage will be 0 here. So when the voltage is 0, okay, now K3 Vi cos phi and K square is here. So K3 Vi cos phi, you know that it's a directional element, as you know it's going to provide a direction. So directional element, and here remaining term is K1 I square. So it is directional restraint over current relay. Remember here it's a directional restraint over current relay, and K4 is spring constant. It's a common for all the relays. Okay, so you don't need to bother about this. Remember here for this case it is K2 will be 0. So directional restraint over current relay is right answer. And the next question, the steady state stability of power system is improved by. So we use a basic formula again as it is, steady state stability they are asking. So P is equal to PSS is equal to EV by X into sin delta, and without disturbing voltage and the delta here, simply we need to reduce the reactance. If you reduce the reactance, it will be increase the power state stability. Suppose see here, as you know the concept of parallel, here we have excess reactance line and here we have excess reactance line is there. When you are operating in parallel, the X equivalent will be XS by 2. So as you are decreasing the total reactance, the power handling capability of the transmission line will be increases. So using double circuit line instead of single circuit line, you can increase the steady state stability limit. Suppose if the question is asked, transient state stability limit can be improved by using, so you can say it is single pole switching, decreasing generator inertia, and reducing the fault clearance time. You can see other options. But in the given question, steady state stability of a power system can be improved by using the double circuit line instead of single circuit line. Okay, so thank you friends. Thanks for watching my video. If you like my video, please subscribe, share and comment. Have a nice day. We will meet you in the next upcoming videos. Hi, hello friends. Welcome to T Academy. Let's continue our Tamil Nadu Electricity Board previous AE paper exam. Okay, the question is here: which of the following relays has the capability of anticipating the possible major fault in transformer? So anticipating means expecting, the fault is going to be expecting. Okay, so it is, the option is bulkous relay. So how is going to detect the bulkous relay? So actually in transformer, we assemble the transformer in the transformer tank. There we'll have a transformer winding like this, okay, which is on the core, okay, which is on the core like this. Now it is also having oil inside. So these are the oil. We can call it a transformer oil. When the overloading and the transformer winding happens, overloading means current will flow. Because of current will flow, there will be I square R losses. We can call it a copper losses. Because of these copper losses, there will be heat. Okay, as the heat is there, so because of that heat, the transformer oil is going to be heated. Generally, you know. Okay, because of that heating, the heat is transferred to the transformer oil surrounding the windings here like this. Now there will place a mechanism such a way that the heat will produce in the oil will causes some bubbles. So I will repeat again. Because of that heat given to the oil, so oil giving hydrogen bubbles like this, small bubbles, like we observed when in our homes, when we cooking with the oil, when oil is heated up, it creates some bubbles, right? So such a kind of bubbles will happen inside the transformer because of overloading. As that overloading happens, it is going to lift the some small mechanism like this to upwards, just like our flushing mechanism. Okay, so this flushing mechanism will moving to upwards. Okay, so that the mechanism will give a alarm first. Okay, it's giving a signal that transformer is getting overheated. After that alarm, suddenly, if it exceeds a threshold value, then alarm will make given signal to the relay. So as the relay is there, so relay is going to be trip here. Okay, so only the relay which will anticipating, that means which is going to say a warning that because of that overloading or something fault happening inside the transformer winding, there will be heat. That heat is more means, okay, the heat is more means the transformer may get damages, like that it gives alarm. So bulkous relay is the only relay which will anticipate the fault, which will expect that the fault is going to come. Okay, other relays are there which is works on the only fault. Okay, when the fault comes, other relays will work, such as overcurrent relay, differential relay, overflux relay. But bulkous relay is the only relay which will expect that fault is going to be occur, so that it will give a signal to the duty operator there. Okay, so that's the answer is bulkous relay is a transformer. And the next question here, okay, 76 question here, you can see here, the corona losses does not depends upon the corona loss. We will write the formula, basic formula here. The corona losses PL is equal to, it is 242.4. So in some text it will be 255 like that, but I am writing, just observe the formula, F plus 25 divided by delta into square root of R divided by D into V naught minus VPH whole square. So it's having units kilometer per phase per kilowatt. Now the corona losses not depending on, so it depends upon the delta value, is atmosphere. Okay, and the conductor size means it's R, and line voltage here it is voltage, and height of the conductor, so it is independent of height of the conductor, but depends upon atmosphere, conductor size and line voltage. Okay, we'll move to next question. Here, consider the single line diagram shown in the figure below if the base voltage is selected on the generator terminal as a 10 kV, so they given a generator voltage as a 10 kV given, what will be the base voltage on the transmission line? Now here there is a generator which will have a voltage of 10 kV, and there is a bus bar here. Let me take bus bar 1, and here is a bus bar 2, and there is a transformer which is a primary side is star, secondary side is delta, and here we have this transmission line. This entire section from here to here, it will be a transmission line, and there is a transformer here delta to star, and this is a bus bar is there like this. Okay, now here what we need to find is, here the generator side the base voltage is given. How much? It is 10 kV, but what will be the base voltage here? Okay, now in the power system, transformer is the only place where the voltage is going to be changed. Okay, so here we'll find the base voltage. How are we going to find the base voltage? So VB2 is equal to primary base voltage VB1 into, now here next transformer is in, so because of transformer we'll take this rating of the transformer, so VT2 divided by VT1, or I can take it is from the number of turns. Okay, both will valid only. Now VB1 is how much? 10 kV base into, alright, VT2 is 132 kV divided by VT1 is 11 kV. Now so 11 1 11 12. Okay, now what is the base voltage here? It is going to be 10k into 12, so which is will be 120 kilovolts is the answer. So for this bit the 3 is a right answer. Okay, I will move to the next question. Now the value of a matrix in x dash is equal to a into x for the system is described by y double dash plus 2y dot plus 3y is equal to 0. So if I write this equation in Laplace transformation, we can write as d square by d t into y of y plus dy by dt into 2 plus y into 3 is equal to 0. Again, if you take in Laplace transformation, I can write s square y of s plus 2 into s into y of s plus 3 into y of s is equal to 0. Now if you make all the y of s is a common here, now what you get? Y of s into s square plus 2s plus 3 is equal to 0. Okay, now here this is the only transfer function that is available. Okay, now we will check this answer. Okay, I don't know exactly what is the exact answer will be or procedure will be, but I'll give a shortcut here. Just take here si minus a in the transfer function and find the data of this. What is the s here? Yes, I means is a identity matrix, so s into 1 0 0 1 minus a value. So I know that I will check the answer directly with the fourth option. Why? Because I know the answer it is. So 0 1 and minus 3 minus 2. Now s 0 0 s, this matrix as it is. Now 0 1 minus 3 minus 2. So if I again find here, what will get here? So s minus 1 plus 3 plus 2. So this is what we'll get here, right? Now we'll cross multiply. So cross multiply means here, sorry, here is going to be here it is s plus 2, sorry, s plus 2 here, right? Make a correction. So s into s plus 2 minus of minus means plus 3 is equal to 0. S square plus 2s plus 3 is equal to 0. Okay, so this is the matrix A. Okay, now we'll move to the next question here, and this is from control system itself. Now okay, see here, the Opulum transfer function of a unity feedback system g of s is equal to 50 divided by s square into s plus 2, the steady state error for unit acceleration input. Now ESS, steady state error, is inversely proportional to 1 by acceleration input. Now what is the k here? So k is equal to limit s tends to 0 s square into g of s. So acceleration input means the input is so parabola, right? Now that is equal to, so limit s tends to 0 s square, g of s means 50 divided by s square into s plus 2. So s square gets cancelled. If you substitute s is equal to 0 here, 50 divided by 0 plus 2, that is nothing but 25. Okay, we'll get k as 225. Okay, 25. Now ess is equal to 1 by k into a. So k, sorry, is equal to 1 by 25 is equal to 0.04 is the right answer for this question. So the answer is 2, 0.04. Next question here. The negative feedback reduces. Negative feedback is going to reduce only the system gain, but it improves the system stability and it increases the bandwidth. How to remember this, sir? Remember here, the negative feedback reduces the system gain, and we know that the product of gain into bandwidth is nothing but a constant. So as we know that the gain will decreases means automatically bandwidth will increase. So the answer for this question is the system gain reduces by negative feedback. The next question here. The transfer function of the signal flow graph is shown in figure here, and its transfer function we need to calculate here. Okay, the transfer function of the signal flow graph is shown here. Now first we will write the forward paths. Okay, so finally we will write the formula. First, forward path gain P1 is equal to, so entire 1. So forward path is this, like this, 1 G1 G4 here, and this G2, and here 1. So x5 and x2 all are nodes, so don't consider it. Okay, so first forward path is G1 G4, sorry, G1 G4, and here it is G2. Is there any other forward path here? Forward path means starting from the R to C, only one line. And here there is another path. Okay, let me correct here. This is this direction. Okay, now next forward path is G1 G4 G3. So where is G1 G4 G3? So G1 G4 will come like this. It will be jump like this and it will go. Okay, now next forward path is P2 is equal to G1 G4 G3. Okay, similar kind of question asked in GATE 2020. So that is today. Okay, what about L1? So loop, sir. Okay, first we'll write loop. So loop means it starts here, I can come back, but the G1 G4 H1 is not a loop. Okay, loop 1 I'll write G1 G4, and here it is H1. Is it loop? Yes, it is a loop only. Next one, loop 2 will write. What is the loop 2 here? Loop 2 is nothing but minus G1 G4 G2 H2. Similarly, what about the loop 3? Loop 3 is equal to minus G1 G4 G3 H2. Okay, so these are the 3 loops here. Now if you apply the Mason's gain formula, what it says is, so transfer function is equal to, it is the sum of the forward paths divided by 1 minus individual loops here. So non-touching loops are, I will consider only one here. So 1 minus L1 plus L2 plus L3. Okay, so add this P1 plus P2 and 1 minus L1 plus L2 plus L3, you will get the answer it as 2 is a right option for this question here. Okay, so hope you did it in the piece of paper and add all these values, you will get the same answer. Okay, so thank you friends, thanks for watching my video. If you like my video, please subscribe, share and comment. Have a nice day. Thank you. Hi, hello friends, welcome to T Academy. Now we will discuss the Tamil Nadu Electricity Board 2018 AE paper, and this is the 4th lecture of this solutions of TNEB AE paper. Now the question is from the control system subject. The characteristic equation of a feedback control system is given by the equation is given 2s power 4 s cube 2s square 5s plus 10 is equal to 0. The number of roots in the right half of S plane are, okay. Now we need to find the right half of the S plane. So to solve this type of answers, I will take the help of RH tabulation, okay. Now s power 4 I will take s cube s square s power 1 s power 0. So first I will take the coefficients. First one here 1. S power term is first one is say 2. Next one it is here, second one it is 2, okay, and third one here it is 10. So I will take this first one, second one, third one. Next s power 3. S power 3 no coefficient is here means we should take it as a 1. After that here it is a 5 and later you can take 0, no issue at all. Now so here important thing is the cross multiplication here. So first you will cross multiply 1 into 2 minus 5 into 2. So what you will get here it is, I will write here 1 into 2 minus 5 into 2. So divided by 1 you can take the coefficient here. That is 2 minus 10 means minus 8 by 1. You can consider as a minus 8 here. Next one 1 into 10 consider 0 here. 1 into 10 minus 0 into 2. So 1 into 10 minus 0 into 2 divided by, so what is here 1. So what you will get, 1 into 10 means 10, 10 minus 0 by 1. So it is 10 here. Now again cross multiplication, minus 8 into 5, 10 minus 1. So minus 8 into 5 means 8 5 is 40. So minus 40 minus 10. So minus 40 minus 10 divided by minus 8. How much you get? 50 by 8 here. So you will get a positive value here. Okay, here you will get 0. Now here what you will get? So 50 into 8 into 10 minus 0 divided by 50 into 8. Directly you will get 10 here. Now you have to observe here how many sign changes are there. So positive here and here also positive. But from positive here one sign change here. So consider it as a one sign change. Next from negative to again positive here there is another sign change. Why? Because plus to minus is a one change, minus to plus is another change. Suppose minus to minus is that means there is no sign change. So here two sign change. Now here positive, so no sign change. Okay. Now from this then RH tabulation, the number of roots in the right half of the S plane is equal to number of sign changes in the first column. So that is the answer is 2 here. So answer is 2. So we'll move to the next question. The peak overshoot of a step input response of an underdamped second order system is explicitly indicative of. Suppose if we take the second order system response here, so like this, now we will get a waveform like this, second order system. Okay. Now this is a maximum peak overshoot and this is the peak overshoots here. So what this peak overshoot indicates, it is the damping ratio they will indicate. So why? Because damping means the decrease in amplitude. So it is going to decrease, finally settle down to some particular value. Okay. And next question, the transfer function of the following polar plot is. Okay. So this polar plot is given. So let me take here 0 degree. Okay. So 90 or minus 270 degrees I will write. Suppose if you go for clockwise direction, it is 0, minus 90 like that I will write. So clockwise direction 0, minus 90, minus 180 and minus 270 like that. So if you are going for counterclockwise direction, generally we will go for counterclockwise direction 0, 90, 180 or 270 like this pattern. Now I will, in the given options, I will take the option as a 3. Why? Because I know the answer is 3. That's why I am taking this answer 3 and I will solve it and show you that it's the right answer. Now for that g of s, you will take this as, so g of s is equal to the third option I am taking 1 by 1 plus st1 into 1 plus st2 into 1 plus st3. Okay, I am taking this 3. Now I will write the magnitude here. So g of s magnitude if you write means, so 1 by square root of 1 plus, if we substitute omega s is equal to j omega t, I'll take omega t1 or omega t whole square t1 into square root of 1 plus omega t2 whole square, sorry, omega t square, mistake, so omega t square into square root of 1 plus omega t 3 square, make a correction here, square, right. Now similarly, if I take a phase angle is equal to, so minus tan inversion of omega t1 by 1 minus tan inversion of omega t2 by 1 minus tan inversion of omega t3 by 1, like that if you take. Now finally, if you draw the curve, draw the magnitude and phase angle values for a different range of frequencies, say 0 to infinity, you will take here. And the magnitude here it is when omega is 0, this magnitude will be 1, as you can substitute here, and infinity means it's 0. Similarly, phase angle I can consider, if you draw here, phase angle will be 0 and here it will be minus 270. That means from this what we can say is, when magnitude is 1, okay, phase angle is 0, so phase angle is 0 here, starting point. Okay, when the magnitude is 0, so magnitude will be 0 here, when the phase angle is minus 270, so 1 is here, 0 is here, the magnitude is specified here. Okay, minus 270 means the curve will reach minus 270 plane here. Okay, like that you can check all the other options and you'll get the answer it as 3 only. Okay, now the question is shifted from control systems to power electronics now. Right, now this question, right, see here, the following figure shows a composite switch consisting of a power transistor BJT in series with a diode. Assuming that the transistor switch and the diode are ideal, the IV characteristics of the composite switch. Okay, we need to draw the IV characteristics, current and voltage characteristics of this switch here. Remember here there are two divisions are there. Okay, first one it is consisting of a BJT, second one is a diode. Okay, so diode, you know that diode will allow current only in one direction. Suppose if the current is flowing in this direction, it will allow, but it will not allow reverse direction. So we can say that it is unidirectional. Understand this point? Unidirectional. And a BJT, generally we have a voltage here, so it is called 0.7 volts VBE, but the switches are here are ideal. That means even if you give 0 volts here, as it between the emitter and base, VB, sorry, so emitter and the base here, if 0.7 volts in case of non-ideal case, it's 0 volts in case of ideal case, it starts conducting. But generally it will have a blocking capability in forward direction. How? Because if the base current is 0, it will not conduct. Sorry, if you give the base current 0, it will not conduct. Once the base current is not equal to 0, if you see the characteristics, it starts conducting. That means the controlling is in the with the help of base current only. Now, and remember that the diode will not have reverse voltage blocking capability. Reverse voltage blocking capability. That means the reverse voltage it will not start generally. So conclusion point here it is, thus BJT is a control switch. With the help of the base current you can control. First point, even if you give forward bias voltage, if you are not giving the base current, then it will not start. Okay, even if you give reverse bias, it will not work. Okay, so the characteristics will be looks like this, that first of all, if you are not giving base current, it will block some voltage. Okay, it's a off state condition. It's a off state condition. Now if you give a base current, it starts conducting, it's a current, so current will have some maximum value, so it is in on state. So general characteristics of an BJT like this, but it will not have reverse blocking capability. That means reverse voltage if you apply means it starts automatically damages. Okay, but the addition of this diode, you are giving some reverse blocking capability here like this. So the characteristics will lie in these three categories. So answer here it is 3 is a right answer for this question here. Okay, hope you understand this point. Okay, if you are not understanding, make it revise again and again, you will get a clarity about this question. Next question, it is from the power electronics only, right? It's an important question. A three-phase fully controlled bridge converter is feeding a load drawing a constant and a ripple free load current of 10 amperes. So constant, okay, constant ripple free, that means it's a pure DC component only at a firing angle of 30 degrees. Okay. The approximate percentage of total harmonic distortion and the RMS value of the fundamental component of the input current will respectively. Remember here that total harmonic distortion is independent of this firing angle, so it will remain at 31% only. That's why in the options they given 31%, 66%. So 31% will be remain same. Total harmonic distortion will not change. Okay, depends upon only waveform. It's not depends upon RMS value or firing angle. Okay. Now next one, the RMS, the value of fundamental component. So RMS value of fundamental component is equal to square root of 6 divided by pi into I naught. So this is formula here. Now square root of 6 by pi into 10, if you solve this you will get it as 7.8 amperes of current. So answer here it is 31% and 7.8 amperes of current. Remember this friends here. Okay, so that's it for this session. Thanks for watching my video. If you like my video, please subscribe and share and comment. Thank you. Have a nice day.
Hi, hello friends. Welcome back to my T Academy. Now let's continue the TNEB electrical paper, AE paper. The question is 87 here. In the circuit shown, an ideal switch AC is operated at 100 kHz with a duty ratio of 50%. Given that delta IC is 1.6 amperes, peak to peak and I naught is 5 amperes. The peak current in S is. So here this circuit is given. As you can see, you can identify it is a buck converter, and here we need to find the current here. So the current, the peak current in switches. Okay. Now there are options are there. First understand the buck converter waveforms, how it is. Now see, if you give a DC supply square waveform like this to this converter, the current will be okay, so rising like this. Why? Because inductor is there, no? Now falls like this, again current will like this. Okay, now in between there is a constant value. This value is I naught, and here entire this one is, it is delta IL here. Now this is I naught and you need to find this peak value. Okay, so peak value here you need to find. Now the current IL maximum value is, it is the average value I naught plus, so if you see here, the entire part is, this entire part from here to here, from here to here, it is delta IL. Now if we want half of this above this portion, so delta IL is going to be delta IL by 2. So delta IL by 2. Now in the given problem, I naught value is 5. So IL max or peak is equal to I naught plus delta IL by 2 from the formula, right? So 5 plus 1.6 by 2, it is nothing but 5 plus 0.8, it is nothing but 5.8 amperes is the answer for this question. Okay, so you don't need to mark up the formulas, just remember the concept, you will get the answer directly. Okay, now next question, it is from the power electronics. A single phase source inverter is feeding a purely inductive load. So understand here, purely inductive load as is shown in the figure. The inverter is operated at 50 Hz 180 degrees square wave mode, assuming that the load current does not have any DC component. So load current does not have any DC component means the output is a pure AC waveform. The peak value of the inductor current will be, okay, so here this is given circuit diagram. Now remember here Vs is 200 volts, inductance is 0.1 Henry. So basic formula will apply, we won't go to depth about the power electronics. So simply V is equal to L into dA by dt you need to consider. Now V is how much? 200. L is how much? 0.1. Now see here, di, difference in current by difference in time. So here you need to remember the concept of this waveform here. Okay, now the current here, the first will flow when the switches are, let's say 1 here, 3, 4, 2. When 1, 2 are conducting, the current will flow like this. Okay, when 3 or 4 conducting, the current will flow like this. That means in the first case current will flow like this, second case current will flow like this. So let me take here current IP, I will take, okay, forward direction, and this one will be reverse direction. Now here di by dt means difference in current. So first current direction positive, minus of minus IP divided by time here dt. So what's the time here given? So time here it is, see how much frequency. So frequency is how much? 50 hertz. So if frequency is 50 hertz, what about the time period? This is 20 milliseconds here. Now observe, for how much time period the waveform is going to change here. Okay, so if you see the waveform here of this inverter, the current waveform will be, no, okay, I'll use square wave here like this. The current waveform will be, looks like somewhere, so it should be something like this. Okay, should be, it is coming like this, it's going like this. Okay, so it is starting from negative itself. Why? Because inductance in nature. Now here if you take the time period, it is only half cycle. So half cycle means it is 10 milliseconds. Okay, now 200 into 10 into 10 power minus 3 divided by 0.1 is equal to 2 into IP. Okay, so 2 100. So finally get IP as, IP is equal to 10 amperes here answer. If you want, you can cross check here. So it is a previous gate question. Okay, so it is a previous gate exam question. You can review the previous gate questions. Okay, now next question here. A single phase fully controlled bridge converter supplies a load drawing constant and a ripple free load current. If the triggering angle is 30 degrees, then the input power factor will be, okay, so tell me the formula for input power factor. So input power factor is equal to 2 root 2 by pi into cos alpha, or I can also write 0.9 into cos alpha is how much? 30. There is nothing but 0.9 into root 3 by 2. So it is 0.7794, approximately 0.78 is the answer. We'll move to the next question here. Okay, see here. 19th question. A variable speed 3-phase induction motor drive obtained by varying applied voltage is suitable for, okay, generally a 3-phase induction motor drive or single phase induction motor drive which can be varied, speed can be varied by applied voltage only. That means here V by F ratio is not constant. Okay, only V is varying, frequency is constant only. So when the frequency is constant, it can be applied to the driving fan type loads where the torque is proportional to square of the speed. So remember, this is an important point. In our homes we use ceiling fans. The ceiling fans is nothing but an induction machine which will run a torque is proportional to speed square. So remember this point here. Next one, the operation of AC motor fed from the current source inverter is characterized by, the operation of AC motors fed from the current source inverter. So current source inverter where the current is going to be constant, the voltage is going to be vary. Okay, is characterized by sinusoidal armature voltage which spikes. Sinusoidal armature voltage with spikes here. Okay, next one. Now this is from the digital electronics. A mode 3 counter is already available. To design divided by 6 counter, further how many flip-flops are required? First of all, for mod 3 counter, how many number of flip-flops are required? For mod 3 counter, we require 2 flip-flops. Okay, for mod 6 or divided by 6 means it's nothing but a mod 6 only. So mod 6 we require 3 flip-flops. Only existing are 2. How much extra we needed? So 2 plus 1 is nothing but 3 flip-flops. So answer here it is 4 is the right option. Next question. Now the given two half adders, what extra 2 input gate is required to build a full adder? Okay, so let me take first 2 half adders. I have one half adder here, another half adder. Let me take the inputs P, Q and the input P, Q here. Okay, so for the first half adder the input is carry in, and here Q is taken from the output here, and the another output is here, and here we get sum. Now here question is, there are two half adders are there. Now which gate is required to make it full adder? So that is nothing but, yes, it is OR gate required. So here get finally carry here. So OR gate is required for this for to make a full adder from two half adders. That's it for this session. Thank you friends. Thanks for watching my video. If you like my video, please subscribe, share and comment. Have a nice day.
Hi, hello friends. Welcome back to T Academy. In this session, I will discuss the Tamil Nadu Electricity Board, okay, AE exam, and it is a question number 94 here, okay. The 8085 instruction that doubles the value in accumulator is. So the answer for this question is add A. What the add A will do is, so add A will do is the content of the operand or added to the content of the accumulator. So what it will do is it will add the content of the operand, okay, to the content of accumulator, and it stores the result in accumulator itself. So stores result in accumulator. Okay, so we'll see the opcode of this this one is, this instruction is, so opcode is add. Okay, so operand may be a read register or memory, and bytes is, it occupies 1 byte, and the machine cycle is 2, and the T states are 4 T states or 7 T states. Okay, so these are additional information which may be useful for your examination. Okay, next question. Next one, the status of the flag that is available in the microprocessor 8085 but not available in the microcontroller 80851 is, it is a 0 flag. Okay, so 0 flag is available in the 8085 microprocessor, but it is not available in 8051 microcontroller here. Okay, next one. This question is from the digital electronics. Okay, now the hexadecimal equivalent of the octal number is so we need to convert this octal number into hexadecimal. First what we will do is we will take this term, so 5 into 10 5 into 8 square plus 6 into 8 power 1 plus 7 into 840 plus 4 into 1 by 8 or 8 power minus 1, you can say, plus 3 into 1 by 8 square. So by solving this you will get it as 375.546875. we convert it into decimal number here, but we want hexadecimal number. So what we will do is we will take this part as it is. So 375 is subtracted by 16 here, because hexa means 60. 23 will get it 368, so 70 here. Again you will take this
16, 23. So we'll get a 7 here. So in this way 177 will get here point. Now next half part is we will take this 0.546875 into 16 here. Okay, now we get it as 8.75. so 8 will be there. Next 0.75 multiplied with 16, we will get it as 12. So 12 in hexadecimal code is equivalent to C here. Now the exact answer is 177.8C is the answer. So for this question, fourth one is a right answer here. Okay. Next one, the number of T states taken for fetching and execution. So fetching and execution of the 8085 instruction, okay, INRM is, okay, so we will write the table here. So opcode is INR and operand is read or write, and it takes number of bytes as 1. Memory cycle is 3, and the T states, it is 10 T states. Okay, so for execution and fetching, so answer is 3 is the right answer for this question here. Next one, the microcontroller 8051 has all the following except, so 8051 is having the built-in timer, 8051 is having a serial communication, and 8051 not having this built-in analog to digital converter. Say ADC it won't have, so it will have built-in read-only memory. So among the 4 options, 3 is the right option for this question here. And next we'll go to the question number 99. The question is here, the discrete time signal x of n is equal to -1 whole power n is periodic with a fundamental period. Now for a signal to be periodic, there has to be the time period such a way that it has to satisfy the condition. So f of n is equal to f of n plus t here. Okay, so capital T. Now the given function is -1 whole power n here. So we will write here -1 whole power n is equal to -1 whole power n plus t here. Now if we rearrange the equation, we can write it as -1 whole power n plus t minus of -1 whole power n is equal to 0. Now if we make the -1 whole power n common here, okay, well what you get is -1 whole power t minus 1 is equal to 0. Now in these two terms, this term never becomes 0, and the remaining term, this may be made equal to 0 here. So based on this, -1 whole power t is equal to 1 here. Okay, so assume here, so -1 is equal to 1 by what times? It may be even multiple here. Okay, so here the t value may be either it may be 2, 4, 6, 8 goes on here. Now if we talk about the fundamental value, so fundamental means t is equal to 2. Okay, so first case is t is equal to 2, the next case is t is equal to 4. So among the option, what they are asking is fundamental value, means fundamental time period is first one. So first one, it is 3 is the answer, and 2 is the correct option here. Okay, so answer is 3 here. Next one, 100 question here. In Gibbs phenomenon, the ringing effect is predominantly present nearer to the, so this question is from the digital signal processing. In signal processing, especially digital signal processing, the ringing effect is appeared as a spore signal. Okay, SP spore is signal, the signal which is nearer to the sharp transition of the signal. So sharp transition of the signal means when the signal is changing from its state, from one state to other state. So at that time there you can see that is a disturbance like that, okay, unwanted signal such as harmonics. So it appears at the band edges here. So near band edges means band edges here. So that's nothing but the answer is here, it is a band edge here. Okay, so for 100 question the answer is 2. Next one, the IIR filter designing involves. Okay, so designing of the analog filter in analog domain and transforming into digital domain is the answer. And similarly there is another option also, another possible option answer also there. So designing of the digital filter in analog domain and transforming into digital domain, so this is also possible. Okay, so because this method is highly advanced. Okay, and designing of the analog filter in digital domain and the transforming into analog domain is a wrong option, and the designing of the digital filter in digital domain and transforming into analog domain also wrong answer. So correct answer for this question is designing of the analog filter in analog domain and transforming into digital domain. Next one is designing of the digital filter in analog domain and transforming into digital domain. So these two are the correct answers for the question. In the examination point of view, those who given option 1 and 2, so they get a equal marks here. Okay, and 3, 4 are the wrong options here. Next one for this session here, for designing a multi-rate LPF low pass filter with a pass band 0 to 50 Hz and a stop band 60 to 280 Hz, the stop band variation stop band deviation 0.001, pass band deviation 0.1, and a sampling frequency fs is equal to 400 Hz. What would be the value of normalized transition width? So the normalized transition width is having a 0.025 Hz. Okay, so the answer for this question is 1 here. Hi, hello friends, welcome to T Academy. Now in this video I'll give the explanation to the TNEB AE paper 2018 here. Okay, so we'll stop up to 102 question in the last video. Now we'll continue from there. The question here it is on the screen is an IIR filter designed by a bilinear transformation. The bilinear transformation is a mapping from, so bilinear transformation is a mapping from analog S plane, okay, analog S plane to digital Z plane. So it is transforming analog S plane to digital Z, so plane here. So this conversion mapping, what we will do is maps analog poles to digital poles and the analog zeros to digital zeros. So analog pole is there means, suppose analog pole is there, this analog pole is transformed into digital pole here, and similarly analog 0 is here, it is transformed into digital zeros here. Okay, so that all the poles and zeros are mapped here. So the answer for this question is 2 is the right answer. So this bilateral transformation, what it do is it will convert the analog S plane to here digital S plane. So answer is 2 is the right answer for this question here. Okay, next question, what is the convolution of the sequence x1 of n is equal to x2 of n of 1 1 1 here? So it's a simple, so we'll do the convolution theorem principle here. As per this principle, what we will do is first we will take x1 of n, so both are same only, 1 1 1, and x2 of n is 1 1 1 here. Now what we will do is simply we will cross multiply, so 1 into 1 we will get it as 1. So similarly again 1 into 1 1 here, again 1 into 1 1. Similarly like that again you take this element and cross multiply here, you will get 1 1 1, and similarly here also 1 1 1 here. Now take this cross mapping like this. So the resultant, first we will take this 1, Next 1 will get it. 1 is the answer. First of all, the resultant convolution will be 1. Now here is a 2 is there, so 1 plus 1 is 2. Now next case it is 3, 1 2 3. Next case again it is 2 here, and last one it is 1. So among the options, check here which option matches with the answer is 1 2 3 2 1. So 1 2 3 2 1 means the 1 is the right answer for this question here. Okay, next one, the question number 105 here. So when the frequency band is selected, we can specify the sampling rate and the characteristics of the pre-filter, so which is called anti-aliasing filter here. So anti-aliasing filter, it is known as AAF. So anti-aliasing filter is a simple low pass filter. Okay, it's a simple low pass filter. So low pass filter, what it will do is, it is going to remove the high frequency signal. It will allow only low pass signal. Low pass signal means low frequency signals it allow. Generally why we use it is, so it is placed before the analog to digital converter. So we will place here anti-aliasing filter here. So this filter is a simple low pass filter with unity gain. Okay, so answer is 4 here. And the next one, 106, which mechanism in control engineering implies an ability to measure the state by taking the measurement at output here? So it is observability. So observability, it is by definition, it is a measure of how well the internal states of a system, so how well the internal states of the system can be inferred or can be altered, from the knowledge of its external output. So answer is observability is a right answer here. Next one, 107, the layer that extends host to host delivery to process delivery is, it is a transport layer. Okay, this question is from the computer networks. So we'll go to the next question of this session. Okay, so those who are new to my YouTube channel, please subscribe to my YouTube channel and share my videos with your friends and prepare well for your exams. Okay, now UDP is a dash protocol. So first of all, what is a UDP? So UDP is nothing but a user datagram protocol. User datagram protocol. Okay, so it's a simple transport layer connections here. Okay, so UDP is a part of internet protocol suite. So it is a part, UDP is a, it's a part of internet protocol suite here. Okay, so UDP is a transport layer connectionless protocol. Next one, the modified Z transform is used. So the other name for the modified Z transform is, it is advanced Z transform. So it is used for the systems having dead time which is not an integer multiple of sampling time. So here we are using this advanced or modified Z transform for the systems who having a dead time is not an integer multiple of sampling here. Next question. Now, increasing the order of the data hold will increase the time delay here. So if you are increasing the order of the data hold means stop here actually. So holding the data means what will do is, it will increase the time delay here. And the next one, A linear time invariant single input single output system has a state space model given by dx by dt is equal to fx plus gu, y is equal to hx. Okay, so where f is given 0 1 minus 4 minus 2, g is given 0 1 and h is equal to 1 0. Here the x is a state vector, u is the input and y is the output. The damping ratio of the system is. So first here what we will do is general formula, we will convert into general form here. So dx by dt is nothing but x dot, we can write it is nothing but ax plus b, your bu we can write. So this is the a is nothing but a, so this is the a and this is going to be g is going to be b and y is equal to c here, actually c. Okay, so if you take this notation, I will write the formula here. The damping ratio of the system will be, so the transfer function formula is transfer function is equal to c into s into I minus a inverse into b plus d. So generally we know this a value. What is a? A is nothing but 0 1 minus 4 minus 2. S, you know, s is nothing but s. I identity matrix, you know, 1 0 0 1. So s into I means this will get it. Okay, now I will write this here formula here. So si minus I will take si minus a whole inverse is equal to, first of all si, what you get, si minus a, what you get here, it is s minus 1 4 s plus 2. So simply subtract this si minus this value here, what you get, 0 1 minus 4 minus 2, we will get this si minus. Inverse means suppose if you take a b c d, d minus b minus a, like that you have to write. So s plus 2 d minus b means plus 1. Okay, and here it is a plus 4 means minus 4 and yes, you will get it into ad minus bc. So 1 by ad minus bc means s into s plus 2 ad minus, okay, so ad minus bc means s plus 2 plus 4 here. So finally what you will get here is, by solving this, substituting c value and b value, everything here, so d in this case is 0. So okay, so simply what you get is transfer function is nothing but is equal to 1 by s square plus 2s plus 4 will get it. If you compare this equation, the standard equation of s square plus 2 zeta into omega into s plus omega n square is equal to 0. So if you compare here, we can say omega n square is equal to 4, so that omega n is equal to 2, will get it. So by comparison here, and 2 zeta omega n, so I'm comparing the characteristic equation. Okay, and 2 zeta omega n is equal to 2 here, you get it, no? So now zeta is equal to 2 divided by 2 into 2, so it is going to 4, it is going to be 0.5. So for this problem the answer is going to be 2 here. Okay, so that's it friends, that's it for this session. Thanks for watching my video. Have a nice day.
Hi, hello friends, welcome to T Academy. In this video we are going to complete the TNEB 2018 Assistant Engineer Electrical paper. So till now we covered 6 parts. This is the last part of this lecture series. Okay, and we'll start the question here. The Z transform corresponding to the Laplace transformation g of is equal to 10 divided by s into s plus 5 is. So for this particular question the answer is 2 into z into 1 minus e power minus 5t divided by z minus 1 into z minus e power minus 5t is the right answer for this question here. And move to the next question. If the modulation index of an amplitude wave, the modulation index of an AM wave is changed from 0 to 1, the transmitted power is. So the transmitted power is increased by 50% here. So how it's going to, we'll see. So it is going to increase by 50%. So let's take the formula for this one is PT is equal to, so PC into 1 plus mu square by 2. So there are two cases are there when the modulation index is changing from 0 to 1. So first we will say 0. So PT 0 means when mu is equal to 0, that implies, so PC is equal to 1 plus 0 square by 2, that is nothing but PC only. Now next case, when the modulation index is changing to new value mu is equal to 1,
that implies, so PC into 1 plus 1 square by 2, it is nothing but 3 into PC by 2. Now the question is how much increase here? So how much increase in the transmitted power? So increase in transmitted power, increase in transmitted power is equal to, so let's take this is a case number 1 and this is a case number 2. Okay, so 2 minus 1 by 1 here, that implies, so 3 into PC by 2 minus PC divided by PC here. So this is nothing but 1 by 2. So in terms of percentage means we can represent it as 50%. So the answer you get it as 50% here. Okay, so next question. Okay, let me adjust the screen here. Okay, if the number bits per sample in a PCM system is increased from n to n plus 1, the improvement is signal to quantization noise ratio will be. So signal to quantization noise ratio is going to be having its formula is 1.76 plus 6 into n. So this is in terms of dB. Okay, let me adjust the screen here. Okay, now when the signal is changed from n, so this is, let's say this is a n case, now it is changed to n plus 1. So signal quantization noise ratio, it is n plus 1 now is equal to 1.76 plus 6 into n plus 1. Okay, it's in dB. Now what they asked is improvement in the signal quantization. Improvement means how much change here. So same as previous case 1 and 2 will take. So we will take the difference here. Previous case they asked a percentage. Now in this case they are asking how much change. So 2 equation 2 minus 1 if you are doing is, that implies 1.76 plus 6 6 into n plus 6 minus 1.76 minus 6n. So 6 and 6n gets cancelled, 1.76 1.76. Finally how much remaining? It is 6 dB. So among the given options the answer is 2 is the right answer for this question here. Okay, and the next question here, in delta modulation the slope overload distortion can be reduced by. So in delta modulation technique the slope overload can be reduced by increasing the step size here. So fourth one is the right answer. Now next we will move to the 116 question number. All right, here in AM scheme is working, sorry, let me this question here, sorry, which of the following analog modulation scheme requires the minimum transmitted power and a minimum channel bandwidth? So it is SSB. Okay, 116. Next question, in a AM scheme is working with a modulation index of 0.8, the power efficiency of this modulation scheme is equal to, so efficiency power efficiency is equal to, so mu square divided by 2 plus mu square, where mu is nothing but modulation index here. So modulation index means how much? 0.8 divided by 2 plus 0.8 whole square. So based on this 0.64 divided by 2.64, if your terms of efficiency means you will take into 100, so you may get it as a 24.24%. So among the options 1 is a right option for this question here. Okay, next one, the bandwidth of a n-bit binary coded PCM signal for modulating a signal having bandwidth of f Hz is, so direct formula here itself, it is n f Hz here. Okay, where is n is the number of bit binary coded and f is the frequency, having a bandwidth of f. And the last question, next question here, the capture effect occurs in, so capture effect occurs in FM. And the last one for this question paper, if there are m messages and each message has a probability p is equal to 1 by m, then entropy is nothing but it is log 2 m. So log base 2 m is the right answer. So that's it for this, that's it friends. If you like this video, please subscribe to my channel and share with your friends. Thank you, have a nice day.